Hello and welcome. Today, we're going to explore a powerful technique that lets us see the invisible world of molecules. We are talking about micro Raman spectroscopy, a tool that gives us a chemical fingerprint of a material from a microscopic spot. To understand it, let's first break it down. Let's start with Raman spectroscopy. Imagine you shine a light on a molecule. This light is made of tiny energy packets called photons. Most of these photons will bounce off the molecule with the exact same energy they started with. This is called Rayleigh scattering. But something special happens to about 1 in a million photons. When it hits a molecule, it either gives a tiny bit of its energy to the molecule or steals a tiny bit of energy from it. This change in energy is called the Raman effect, and the resulting scattered light is called Raman scattering. The key point is that the amount of energy lost or gained is a unique signature for that specific molecule, just like a fingerprint is unique to a person. Now, let's add the micro part. This simply means we combine the Raman technique with a high-powered optical microscope. By doing this, we can focus the laser light down to an incredibly small spot, often less than 1 micrometer in diameter. This allows us to analyze a very specific point on a sample, like a single particle, a defect in a crystal, or even a part of a biological cell. So how does it all work together? A laser beam is directed through the microscope's objective lens and focused onto the sample. The light interacts with the molecules in that tiny spot and scatters in all directions. The same objective lens collects this scattered light and directs it into a device called a spectrometer. The spectrometer separates the light by its energy, much like a prism separates white light into a rainbow. A very sensitive detector then measures the light, specifically looking for those rare photons that have undergone Raman scattering. A computer then plots this information as a graph, which we call a Raman spectrum. This spectrum shows peaks that correspond to the specific energy shifts, revealing the molecular fingerprint of the material being analyzed. The applications are incredibly diverse. Material scientists use it to identify polymers, check the quality of semiconductors, and study carbon materials like graphene. Geologists can identify minerals in a rock sample without destroying it. In biology and medicine, it can be used to study single cells, identify bacteria, or detect disease markers. It is even used in art history to analyze the pigments in a famous painting to determine its age and authenticity, all without causing any damage. In short, micro Raman spectroscopy is a non-destructive way to figure out what something is made of on a microscopic scale. Thank you so much for watching. We hope this gave you a clear understanding of this amazing technique. If you found this video helpful, please give it a like and consider subscribing to support the channel and see more science explanations. Let us know in the comments if you have any questions or what topic you would like us to cover next. See you in the next video.